Okay, so the recording has started. So let's dive into today's lecture. So we will continue our discussion on the, introduction to machine learning today as well. So let's start. Okay, we'll start with the discussion on, the introduction to machine learning. Okay, right. I think in the last class we discussed up to here. We looked into in the last class we looked into this thought experiment. We discussed about this thought experiment as well, and then we went on to discussing, what do you mean by a learning problem? What do you mean by a program that is learning? What does that mean? And we know that a program, we can say that a program is learning if its performance improves with experience, right, Nakina, right? I hope you remember when I drew a graph like this. Imagine performance. If we plot a performance of solving a task on the y-axis against experience on the x-axis, and we plotted we experience and we drew a graph last class, and we showed, well, it could have, with zero experience it solves the task but with low accuracy, but with experience its performance improves if it's like this. So with the experience the performance improves. Then we can say that this particular program is learning, because it's learning from the experience, it's learning from the data. The more the data that you give, the more experience it gathers, and the better it does in terms of performance, right? Yeah. So the way I can distinguish a program that is learning from the programs that do not learn is that the programs that learns improves in performance with experience, right, Nakina? Is that clear? Yeah. Eta thik ache shobar?
Yes, sir.
Right. So we discussed this one in the last class, and then we saw certain examples like checkers learning problem declam, handwriting recognition problem dekhechi last class. So we discussed robots driving learning, robots driving a car. Okay, how does it do that? How does it do that? We looked at that particular problem as well. And we also discussed about classifying an incoming email as either spam email or a regular email. So that's something we have seen in the last class, right? So this is what we have done in the last class, right? So we'll start from here. Now we are now interested in programs that learns. Okay, that's machine learning about. In machine learning, we will always write programs or things that will learn from the data. Data is the fuel of machine learning. Okay, the more data it works on, the more experience it has, right? So we're now going to look into, okay, the learning problems. So we can have programs that do not learn. We can have programs that learns. So programs that do not learn is not the topic of this course. Okay, so forget that. Now we're going to look into those programs that learn. Okay, and it turns out that there are different kinds of learning. So we would like to look at what these different kinds of learning are. Okay, now the two very important or two very popular kinds of learning that many programs learn, machine learning programs learn, are something called supervised learning and unsupervised learning. So we'd like to see what do we mean by supervised learning, what we mean by unsupervised learning. There's also something in between which is called the semi-supervised learning, which uses which uses both supervised learning and unsupervised learning to do something. We will look into these examples later on. Semi-supervised learning key, the purpose key, we'll see that later on. I just wrote it over there. So semi-supervised learning comes between supervised and unsupervised, but we're not going to discuss today what is the job of a semi-supervised learning. We would like to really understand what's the difference between supervised learning and unsupervised learning. There is a third popular type of learning as well in machine learning called reinforcement learning. That's the third kind of learning. Okay. In this course, we are not going to discuss about reinforcement learning. We will not have the time for that. But maybe if we have time, maybe at an introductory level, we can go ahead and discuss reinforcement learning. But the bulk of this course is on these two kinds of learning. which are the supervised learning and unsupervised learning. So let's try to understand first of all, because we're still looking at machine learning at an introductory level. So let's just try to understand what these learning are and how these learnings are different from each other. Okay. So let's get started. So far, is it okay? Yes?
Yes, sir.
Yes, sir.
Yeah. So let's go ahead. Now, the very first kind of learning that we will be now talking about is something called supervised learning. Now, what is supervised learning? Now, a supervised learning, what does this word mean, supervise? Any idea the word supervise?
Something like that.
Yeah, so supervised learning will have a supervisor. That's why it's called supervised learning, right? Now, what is a supervisor? We will see that, okay? Now, let's see with an example what a supervised learning is and what does it do. In supervised learning, the algorithm builds a mathematical model from a set of data that contains the input and the desired output. Now, this is very important and we will try to look at it and understand what it means. Now, it says that in supervised learning, the algorithm builds a mathematical model, or just simply say a model, from a set of data that contains the input and the desired output. Okay. So in any machine learning problem, we have data. That's the first thing that we have. Without data, we don't have machine learning, right, Nakina? So we have got some data. Clear, Nakina? Yes?
Yes.
Yes.
Okay. So what you do is in supervised learning, you have a algorithm, okay? Or you have, let's say you've got an algorithm, machine learning algorithm, okay? And a learning algorithm, let's say this is a learning algorithm, okay? An algorithm that learns from the data, okay? So you've got a learning algorithm. You apply the learning algorithm on the data, right? Thank you. Now, yes. Now, once you apply the learning algorithm on the data, what do you get out of that? You get a model. Is that right, Nakina? Clear?
Yes, sir. Yes, sir.
Yes?
Yes, sir.
Hello?
Yes, sir.
Okay,
Yes,
so
sir.
that's what happens. So what it says, that in supervised learning, the algorithm builds a mathematical model. So it builds this mathematical model from a set of data. So you apply the learning algorithm on the data and you get a model. Is that okay, Nakina? So that's what happens. Now we will talk about what does this model do, what can we do with the model and stuff like that. We'll talk about that. But that's really what happens. A learning algorithm is applied on the data and it creates a model. Now, this is true for whether it is supervised learning or unsupervised learning, doesn't matter. It's true for all kinds of, machine learning problems, okay? So you apply the learning algorithm on the data and it uses the data to learn some certain things about the data, and thus it creates a model or a representation of that data. Is that okay, Nakina? So that's what it does. But the way the supervised learning is different from unsupervised learning is in terms of the data. What kind of data that we have? Data term of the kiki ache. What are the different things that we have data that that makes it a supervised learning or an unsupervised learning problem? So let's see what happens in a supervised learning. In a supervised learning, the data that you have, contains two things. Number one, input and the desired output. Okay, so these data that you have, right, this data on which you are applying the learning algorithm that you have contains two things. One is the input and the two is the desired output. Okay, now let's focus on this one. What does that mean? It contains inputs and desired output. Okay, mathematically we can represent as x comma y. Now sometimes this x, actually I should write it with capital X, okay, and this y is a small y, okay. So what it contains is the data should contain x and y. So that's what happens in a supervised learning. So in unsupervised learning, the data should not contain x and y. It should contain something else. We'll look into unsupervised learning later on, but let's now focus on supervised learning. So in supervised learning, the data you have contains two things. Number one is X and number two is Y. Is that okay? Yes?
Yes, sir.
So these are the things that these would contain. Now what is X and what is Y? What is X? What is X? X is the input and Y is the output. Okay? All right. Now let's try to understand a little bit more. Now X is an input, Y is an output. X is also can be referred to as, rather than calling it an input, we can also call it as a feature. Feature. Okay? Right? Okay. X is a feature, a predictor. Sometimes we call it a predictor. Okay? Y is an output. All right? Y is an output. Sometimes we can also call it a target variable. Okay? These are the different names that we use. Okay? Clear, Nakina? Yes? Okay? Target variable, output. Things like that. Okay? So now let me give an example. Let's try to understand this one with an example. So we are giving you a toy example over here. So let's say here is a toy example. Okay? Here's a toy example or a toy data set. Now, why do I call it a toy data set? The reason why I call it a toy data set is because in reality, this is a very poor data set. It contains how many entries? How many entries does it contain?
14.
Huh? Any idea? 14. So it contains 14 entries, 14 data. So this data set, what does a data set contain? A data set comprises of data, right, Nakina? Yeah? All right. And these 14 data makes this data set. Now, in reality, this is a very poor data set, right? Ato choto data set, it's very hard to actually get something useful. But whenever we will be discussing concepts in the class, okay, we will be discussing, we will take examples with small data sets, okay? এরকম ছোট ছোট data set দিয়ে আমরা দেখব, কিন্তু যখন আমরা প্রজেক্টে অ্যাপ্লাই করব, of course the data set should be much larger than that. ঠিক আছে? Okay, right? The reason why we will look at small data set, or I call it a toy data set, because it then helps us to understand the concepts much more clearly. Okay, so that's the reason why we often would use these toy data sets. Okay, so if we look at this toy data set, let's try to understand what's happening here. Okay, let's take this. Let's discuss this the story of this data set. Imagine that there are two friends, okay, and these friends are Alice and Bob. Okay, so Alice and Bob are good friends, okay, or we will just call it A and B. That's why we call it Alice and Bob. Okay, let's say they are very good friends, and let's say Bob likes to play golf. Okay, so let's say Bob is interested playing golf. Okay, and some days Bob goes out and play golf, and some days Bob does not play golf. Alice wanted to actually, let's say, understand when does Bob like to play golf and when does Bob not like to play golf outside. So Alice wanted to understand the Bob's behavior, and Alice wanted to understand this systematically. Okay, so this is what Alice thought. Okay, so Bob, some days I see Bob go out and play golf. Some days I see Bob do not like to go out and play golf. He just stays inside his house. Okay, so let's try to understand, when does he like to play golf outside and when does he like to stay inside? And then she thought maybe it depends on certain parameters, okay? And these are the parameters she came up with, okay? Maybe it depends on the outlook. ঠিক আছে? বাইরে কি অবস্থা? Is it sunny? Is it overcast? Or is it rainy? ঠিক আছে? Okay, so the outlook parameter can have 3 values now. The outlook parameter can have 3 values, which are it is sunny, overcast, or rainy. Is that okay, Nakina? Yeah, ঠিক আছে?
Yes, sir.
Yes, sir.
Then she thought, yeah, it might also depends on the temperature, and she measured the temperature in relatively, so not really in degrees Celsius or in Fahrenheit. So she measured it relatively. Is it hot outside? Is it mild, or is it cold? Okay, so these are the 3 values of temperature. So these are, categorical values, really, are nominal values. Okay, all right. So they're not numbers. They're just some categorical values. Okay. And maybe it also depends on the humidity. Is the humidity high? Is the humidity normal? Okay, so it could be high or normal. Okay, so let's say high or normal. That's the only values that humidities could have now. Okay, high or normal. Okay. And she also thought maybe it also depends on whether it's windy outside or not, because after all, Bob is playing golf, and maybe whether one can play golf well or not depends on whether there's wind outside or not. So is it windy or is it not windy? So the possible values are true and false. Okay, so these are the 4. Sorry, how many parameters? 4 parameters, not 5. 4 parameters that she has taken. Okay, all right. She has thought of might be affecting or might be actually making the Bob to decide whether he's going to play golf outside or not. So what are the 4 parameters she looked at? Outlook, the temperature, humidity, and windy. Is that clear, Nakina? Yes?
Yes, sir.
Okay. Now she wanted to understand this one. And so she decided, okay, I'm going to observe Bob for 2 weeks. That's 14 days, 2 weeks. Okay. And I'm going to record whether Bob is really going to play the golf outside or whether he's not going to play golf outside. And I'm going to record what are the values of these parameters. So that's what she has done. So let's say Alice has done that. And so she has these 14 entries. Okay. So on the first day, the outlook was, for example, sunny. It was hot outside. Humidity is high, but there was no wind outside. And she observed that Bob did not go outside and play golf. So she recorded as a no, that Bob did not go outside and play golf. The second day, it was sunny, hot, high, and it's also windy. But Bob still did not go outside and play golf. Okay. On the third day, okay, it was overcast, it was hot, high humidity, and it was not windy. But now he saw, well, Bob actually played golf outside. And this is how she has recorded 14 entries. Okay, Nakina, clear? And now she thought of, okay, now we have some records of Bob playing golf outside or not. And now let's say we can look into this, data, this small data, to really understand if there is a pattern or not. Is that right? Yes? বুঝতে পারছো? Yeah.
Yes, sir.
So this was her scientific way of thinking or trying to understand what are the parameters that affected Bob to go outside and play golf or not. Okay? So she wanted to really look at it in a scientific way, and that's what she has done. Okay, all right. So that's how you have a data set. And মজার ব্যাপার হচ্ছে machine learning works because আমাদের data around us, ঠিক আছে, has patterns, and because there are patterns, it's all about recognizing these patterns and understanding these patterns. ঠিক আছে? Anyway, so far is this okay? Is this data set collection? It is a story about this collection of data is okay or not? It is clear, Nakina? No? Are we okay? Okay.
Yes, sir.
Now, if that's
Yes,
okay,
sir.
let's clean up this mess a little bit. Okay. And
Sir, can I ask a small question?
follow.
So, is there like a standard number of data instances?
We'll come to that. We'll discuss this one. Okay, sir?
Okay, sir.
Okay, maybe bit later, but we'll discuss this one. Okay. All right. So now if you look at this data set, now let's look at this data set very carefully. What are these? এগুলো কি?
Number.
না, এক একটা রো কি?
So data instances.
Data instances, right? Okay, these are entries, you can say, or we would like to call instances. Each of them are instances. এক একটা particular instance. There are 14 instances altogether, and each of them are instances of their own. Clear নাকি না? Yes, day 1 এটা, day 2 তে এটা হয়েছে, day 3 তে এটা হয়েছে, and so on. Is that okay so far? নাকি না?
Yes,
Yeah.
sir.
Yes, sir.
এখন ভালো করে দেখো, what are the parameters here? এখানে কতগুলো প্যারামিটার আছে?
So 4.
How many parameters did Alice think of? 4, right?
Four.
Again, these are the parameters she thought of. Okay,
Yes.
might be affecting Bob. Okay, might be affecting Bob's decision of playing golf outside or not. Okay, all right. So she plans to see how these 4 parameters is affecting this 5th parameter, right? Nakina? Yes.
Yes, sir.
Yes, sir.
That's what we are interested in. That's what Alice is interested in here, to see the 8 parameters. How is it affecting the Bob's behavior of playing golf outside or not? Right, Nakina? Clear?
Yes, sir. Yes, sir.
ঠিক আছে? So if you think very carefully, I could therefore now say these are what? Sorry. These are what? এই চারটা কি? এই চারটা হচ্ছে input. Right? And এইটা কি? This is the one that is the output, or this is the one that we would like to predict correctly, right? Nakina? This is what we want to understand. This is what we want to see. What is this one? আমরা এই চারটা থেকে এইটাকে কি ম্যাপ করে বলতে পারি কিনা? ঠিক আছে? Is it right নাকি না? So if you really think carefully, this is what Alice was thinking of. ঠিক আছে? Now you have got 4 inputs. These are outlook, then temperature, humidity, right? And finally, is it windy outside or not, right? Okay, এবং এই চারটা ভ্যালু থেকে Alice would like to say whether he is going to play golf outside or not, right? নাকি না? Clear? Yes.
Yes, sir.
That's what basically is the motive of Alice. That's what she wanted to do. So really what she wanted to do, she wanted to learn a model. She wanted to learn a model from this data that would be able to map these inputs to these corresponding outputs. So by looking at this from these inputs, she wanted to be able to predict this output. Clear nakina? Yes.
Yes, sir.
That's the main motive. That's the main goal. Okay, that's why she collected this data, so that by analyzing this data, maybe she can now really understand যে এই চারটা ভ্যালুস গুলো different values কিভাবে এই প্লেটাকে এফেক্ট করে, ঠিক আছে, and is there a decision making process or not, ঠিক আছে? Okay, that's what she wanted to understand. Okay, so these inputs that we have, we would represent them as x mathematically, and this output that you want to predict is y. Is it clear, Nakina?
Yes, sir. Clear.
Yeah, so that's why we say that in case of supervised learning, what happens is that the algorithm builds a mathematical model from a set of data, and the data set that we have will contain 2 things: the input and the desired output. The input is x, these are the different value x, these are the different features. In this case, x is outlook, temperature, humidity, windy, and output is here y, which is whether he's going to play outside or not. Clear, Nakina? Yes?
Yes, sir.
So that's really what is interested in, what she's interested in. ঠিক আছে? Okay. In supervised learning, whenever we're going to talk about supervised learning, that's what happens. So whenever you're going to collect the data, you're going to collect the data of X, all these parameters that affect the Y, and also you collect the value of Y. What is that Y? What is that Y value? And then what happens is we're going to discuss about how machine learning algorithms work. But in supervised learning algorithm, সে কি করে এই x এর ভ্যালু এবং করেসপন্ডিং এই y এর ভ্যালু কিভাবে হচ্ছে, মানে যেটা দেওয়া আছে কারেক্ট ভ্যালুটা, সেগুলোর মধ্যে প্যাটার্ন খুঁজে it does lots of very interesting things, and it comes up with a particular model that actually tells how is this x related to this y, or how can I use this x to predict what's the value of this corresponding y. Is that clear, Nakina? Okay.
Yes, sir. Yes, sir.
So supervised learning is supervised learning কেন বলছি? Because we are supervising by giving the correct y value as well. ঠিক আছে? We are giving the correct y value for these corresponding x's as well, and that's why it is a supervised learning. So as if we are being we're playing the role of a supervisor by giving the correct value. Okay, these are the x, these are the inputs, and these should be the correct output. Okay. All right, so you have got a data set. So start learning from here and see whether you can come up with certain model, certain way of, being able to say how this X is related to this particular Y. Is that okay? Nakina, clear? Okay, so what's the ultimate goal? Eta kore labta ki? Eta kore labta hocche, এখন on a 15th day, now let's say Alice has learned from this 14 data, some sort of pattern, some sort of way of looking at this input, okay, to predict the output. Okay, on our 15th day, maybe it was a very different kind of day. Maybe it was I don't know, maybe it was sunny, maybe the temperature is let's say the temperature is mild, or let's say the temperature is okay, the temperature is hot, let's say hot. Let's say the humidity is normal. ঠিক আছে? Let's say the windy is false. এরকম কোন ডেটা কি এখানে আছে? সানি, হট, নরমাল, ফলস। দেখো তো, সানি, হট, হাই, এটা নরমাল না। সানি, হট, হাই, এটাও না। আবার সানি কোথায়? এখানে। সানি মাইল্ড, তাহলে এটা হলো না। সানি কোল, এটা হলো না। সানি মাইল্ড হলো না, তাই না? নাই, আছে এরকম এক্স্যাক্টলি এই ডেটাটা আছে নাকি নাই? নাই, তাই তো? So now we have a 15 day, and the idea is a 14 days থেকে যদি if we learn a model, we should be able to predict what will Bob do, how will Bob decide on this particular day, which we do not have in this data. Clear, Nakina? Is that okay? So the idea is, from the data set, we want to learn a model. We want to learn a representation. এবং এই মডেলটা যদি শিখতে পারি, model of what? Model of how this input is related to output. How does this input, change the output? ঠিক আছে? If we have some sort of model like that, ঠিক আছে? Now, if we have a new data, এরকম ডেটা আমরা এই যে ডেটা দিয়ে শিখলাম, যে ট্রেনিং ডেটা, এরকম না, it's a different data. We should still be able to predict how would Bob respond on that particular day. Is that clear, Nakina? That's the whole idea of collecting this data and learning the model representation from the data. Did you get the point, Nakina?
Yes, sir.
Yeah, so that's what really we want to do. So what happens in a supervised learning? Supervised learning, unsupervised learning we'll discuss a little later, but supervised learning, how does it, what is the main property of a supervised learning? The data set that we have will contain data which has X as well as corresponding Y. That means the list of features values gola, and corresponding Y এর ভ্যালুটাও দেওয়া আছে। এরকম যদি থাকে তোমার ডেটা সেটটা, then this data set is in a format or এরকম ভাবে আছে that we can use this data set to do some sort of supervised learning. ঠিক আছে? Okay, clear? So think about this, what would be unsupervised learning? কি মনে হয়? Unsupervised, something is missing that we have in supervised learning. What would be the thing that's missing? Output. We will not have this y. এমন যদি হতো আমার যদি এরকম কোনো y নাই, ঠিক আছে, শুধু x আছে, ওকে, so শুধু x থেকে আমরা কি করতে পারি, we'll see that, ঠিক আছে, but if you don't have that y, then we can apply unsupervised learning, okay, মানে এই ক্ষেত্রে হয়তো unsupervised learning use করে খুব একটা লাভ হবে না, but there are certain cases where we can use the unsupervised learning to do very, very important tasks, and we will be discussing that as well today. Is that okay so far? Clear? Yes?
Yes.
Any questions? Are we good so far?
স্যার এখানে আপনি ইনপুটস এন্ড ডিজায়ার্ড আউটপুটস বলছেন আপনার, তো আউটপুট কি একটার বেশি হতে পারে একটা মডেল থেকে?
আইডিয়ালি একটাই আউটপুট, একটা ইনপুট একের বেশি হবে, বাট আউটপুট আইডিয়ালি একটাই, বিকজ উই আর প্রেডিক্টিং অনলি ওয়ান থিং, ঠিক আছে? ইজ দ্যাট ওকে?
ওকে স্যার,
ঠিক আছে, ওকে. So moving on, so what happens in the supervised learning? So in supervised learning, the very first thing, we have a labeled data set. Now what does labeled data set mean? That means we have a data set where we have values of x as well as with what is the correct y value that has been also labeled. Okay, so if the correct y value is given, if it's labeled as well, that's called the labeled data set. So we have a labeled data set, okay, which we use as a training data. We supply this data set onto a learning algorithm, and the learning algorithm uses this data set to produce a hypothesis, or we also call it the model. There are just different names, hypothesis or model. Is that right, Nakina? So once we have this model or hypothesis, what happens is we now have a representation of the x, how x is related to y. X এর ভ্যালুস গুলো দিয়ে আমি y কে কিভাবে প্রেডিক্ট করতে পারি, and what's the whole purpose of doing that? Now if you have a new data, so when you have a new data, so that means now you have got different x values, okay, so you apply it there on this model, and you should be able to, you know, estimate or predict the corresponding y value. That's the whole point. Is that clear, Nakina? ঠিক আছে? Is this diagram okay to everybody?
Yes, sir.
Yeah.
Yes, sir.
Now we are talking about supervised learning. So supervised learning about দুই ধরনের হতে পারে. So machine learning, supervised learning, unsupervised learning. Supervised learning can be of two types. One of them is called classification. Another one is called regression. Okay, so it could be either a classification problem or it could be a regression problem. So let's try to understand the difference. It's very simple. So let me give an example of classification and one example of regression, and then you are clear. So here we are. So we have a machine learning problem, ML problem. Okay, this machine learning problem can be solved using supervised learning. Maybe you can apply supervised learning, or maybe unsupervised learning. At this moment, we're not talking about reinforcement learning, so don't worry about that one, okay? So let's say we're just talking about supervised learning and unsupervised learning. Unsupervised learning. These are the two basic learning techniques that we have: supervised learning and unsupervised learning. Okay. If we are talking about supervised learning, that means when will it be supervised learning? It will be supervised learning if the data set that we have contains x as well as the corresponding y. Is that okay, Nakina? Yes?
Yes, sir.
If the data set that we have only has x but no y, that means I can now apply unsupervised learning, perhaps. Is that okay? Clear? Hello?
Yes, sir.
Yes, sir.
Now, this supervised learning, now we focus on supervised learning. This supervised learning can be solving a classification problem, or it can be solving another kind of problem called regression problem. So it's either solving using the supervised learning technique, you're solving either a classification problem, or you're solving something called a regression problem. Okay, so when do I know whether I'm solving a classification problem, and when do I know whether I'm solving a regression problem? Whether I'm solving a classification problem or a regression problem depends on the value of y. ঠিক আছে, এই যে supervised learning এ x and y আছে, এই y এর ভ্যালুর উপর ডিপেন্ড করবে if it's a classification problem or is it a regression problem. Okay, so let me explain this one. If your y, the y that you are going to predict, if that y is a discrete value, if y is discrete, then this is definitely a classification problem. If the value of y that you have is continuous, not discrete, it is continuous, then we are solving continuous, right? Okay, then we are solving the regression problem. Is that okay? So in case of supervised learning, the data set that we have contains both x and y. So the data set has both x and y, that we understand. And so if the data set contains both x and y and you want to use that, so you need to apply supervised learning. Now then you look at the value of y. If the value of y is discrete, then that problem that you're solving is a classification problem. If the value of y is continuous, then the problem you're solving is a regression problem. I think some examples would make things clear. Okay, so first, supervised learning, we can have a classification problem or a regression problem. Now, in case of classification algorithms, these are used when the outputs are restricted to some discrete set of values. That's what we said. Okay, the output, that's y, is discrete. Okay, and in regression algorithms are used when the outputs have continuous values. Output is y, that value is continuous. Okay, now can you tell me what's the difference between discrete and continuous? That's very important, and you're supposed to know this one, right? Can you tell me what's the difference between discrete and continuous? Anyone? Hello? Discrete, continuous, এগুলো নাম তো শুনেছেন নাকি না?
Yes.
Yeah, what do you think? What do you think discrete means?
So in discrete, we consider the whole numbers, and in continuous, we also consider the numbers after decimal point.
That's not true. That I know what you're saying, but that's not really true. Anybody else? What do you think is the difference between discrete and continuous?
Discrete means দুইটা আউটপুট মানে ট্রু অর ফলস, ইয়েস অর নো হবে, আর কন্টিনিউয়াস অনবরত চলতে থাকবে আর কি, এরকম কিছু।
But then again, true and false যদি তুমি বলো, তার মানে it has two possible values. Whatever if it has three possible values,
discrete is
হবে না?
it's countable.
Discrete isn't it like countable?
Continuous
Like, মানে
আচ্ছা, answer me this question. দেখি।
height weight হচ্ছে discrete.
Yes, sorry, say that again.
তার height weight এগুলা হচ্ছে discrete data, আর infinite কোনো ডেটা থাকলে ওটা হচ্ছে continuous data.
কোনটা হলো কন্টিনিউয়াস ডেটা একটু জোরে বলেন।
স্যার যেটা ইনফিনিটলি চলতে থাকবে।
আচ্ছা, let's infinite যেতে থাকবে, আমি এক্স্যাক্টলি জানি না what you mean by that. ঠিক আছে, because it's very important to be able to correctly distinguish them. Because if you don't correctly distinguish them, you will not understand the very basic things right now. Okay, আচ্ছা আমরা একটু দেখি, let's try to understand this one. Okay, now tell me this one, answer me this question. ঠিক আছে, so let's say we have got some discrete values. Can discrete values have a maximum value and a minimum value? Discrete values ki maximum বা minimum value কি হতে পারে?
No, sir.
নো স্যার।
হতে পারে না? Are you sure? Why not?
স্যার হতে পারে।
Say that again. আবার বলো, কেন হতে পারে না? Okay,
discrete
so
values
whether it's a discrete value or a continuous value does not matter. It can have in maximum value as well as minimum values. Acha, let me give an example. Listen to my example and then tell me. Imagine you go to a shop to buy a pair of shoes. Okay, okay, and now of course, if you go to a shop to buy a pair of shoe, they might ask you what's the shoe size. So what is the shoe size now? Okay, the shoe size could be, well, depend for different ages, for different size, but let's say the shoe size can be 5, 6, 6.5, 7, 7.5, and 8. ধরো এই কয়টা shoe size তাদের কাছে আছে, ঠিক আছে? So they have a shoe with these shoe sizes. Now look at this one and tell me, is it discrete or continuous?
Discrete.
Discrete.
So it is discrete. Why not continuous?
So because it's yeah, it's a particular value.
Right, এখন আসি particular value. তার মানে এখন certain things that you've been saying is all wrong. Someone said, well, you know, discrete can be of whole numbers, continuous can be, you know, not whole numbers. But you see, 6.5 is not a whole number. It's a fraction, right, Nakina? Yeah. So discrete values can be also fractional values. That's the first thing. So discrete is সাথে fractional values naki non-fractional values, it has no relationship. Discrete values can be also fractional values. Correct, Nakina? Clear? First misconception. Is that okay now?
Yes, sir.
Okay. Second one, I asked you guys, can discrete values have a minimum value and a maximum value? And most of you said no. But now if you look at this data set, isn't 5 the minimum shoe size that you have and 8 the maximum shoe size that you have?
Yes, sir.
Correct? তাই না? তাহলে discrete values can also have minimum and maximum values. Am I clear, Nakina?
Yes, sir.
Okay. So be sure. That's a discrete value as well. So discrete values can be can have minimum value, maximum values, can be fractional, can be whole numbers, does not matter. But this is not continuous. Why is it not continuous? Now you tell me, why do you think that this is not continuous?
So for it to be continuous, it could have been any number, like say between 5 to 8. So like
Excellent, excellent. That's the whole point. So a continuous number also has a range. Continuous number এমন না যে এটা minus infinity থেকে plus infinity, it can take any value. No, it can take values any numbers within this range, but it should be able to take any values. Right, Nakina? Yes? Okay. Now you see discrete values also has a range. There's a minimum value and there's a maximum value, right? But it cannot take any value between these minimum and maximum values. It can take certain values from minimum and maximum values. So if it can take certain values within a given range, then this is a discrete set of values. Right, Nakina? Okay? So can I therefore say discrete set of values contain certain values within a given range? Yes or no? Yeah? ঠিক আছে?
Yes.
Yeah. And what about continuous set of values? Continuous set of values can take any values within a given range. ঠিক আছে? Okay, all right. So remember, if the value of y is discrete, it's a classification problem. If the value of y is continuous, it's a regression problem. We'll come to that, but আমরা discrete or continuous I একটু clear করে নিই নিজেরা, কারণ এটা clear না হলে অনেক কিছুই clear হবে না. Okay, so let's have a look here. Go to the paint. Okay, let's take this one. Now tell me, you are measuring height of children in a class. Measuring height of children in a class. Okay, measuring shoe size. Okay, right. All right, classifying whether an iris flower whether iris flower বাদ দিই, whether গতকালকে দিয়েছিলাম ইয়ার কথা তাই না, leaf, rice leaf, whether a rice leaf is a diseased leaf or not. Healthy leaf na diseased leaf, right? নাকি না? Okay, all right. Identifying a tumor to be benign or malignant. Measuring sea level. Okay, measuring stock price. I'm going to give you some examples and let's try to understand this. Stock price. ঠিক আছে? All right. Identifying a handwritten character, a handwritten Bangla character. Character. Okay. Then scoring a script, an exam script. Automatically. Now let's try to see এগুলা যেগুলো করবো এগুলা discrete value নাকি এগুলা continuous value. So let's see each example. Measuring the height of children in a class. Let's imagine you go to a particular class and you measure the height of the children. So you have got all these children in a class and you just measure their height and you record that. So you have a record of height of the children. Height of children measure করছে. Is it a continuous value or discrete value? What do you think?
Discrete.
Continuous.
Discrete na continuous?
Continuous.
Continuous. Someone say discrete. Why discrete and why continuous?
So continuous maybe এটা একটা রেঞ্জের ভিতরে যে কোনো নাম্বারই হতে পারে.
It can be anything in centimeters, right? Nakina, clear?
Yes, sir.
Okay.
Yes,
If you're measuring the heights in centimeter, someone can be, I don't know, let's say someone can be 60 centimeter, okay. let's say children, right? Okay, 65, 64, 63. It can take any values. 62.5 centimeter legal values, right? So because it can take any values, all right, and of course there will be a range, there will be a maximum value and a minimum value. Because you can take any values, so it must be therefore continuous, not discrete. Is it clear, Nakina? Yes?
Yes, sir.
Yes, sir.
What about if I measure
Yes.
shoe size? Shoe size is example take it's what? It's what? Discrete or continuous? Sorry?
Discrete, sir.
Measuring
Discrete.
shoe size? Discrete. Classifying whether a rice leaf image is a diseased leaf or a healthy leaf. Let's imagine we have a rice leaf image we give, and all it says is it's a diseased leaf or it's a healthy leaf. That's the key.
So continuous.
Discrete, because the outputs are either diseased leaf or healthy leaf, nothing else, right?
Yes.
Okay,
Yes,
so
sir.
this is an example of a discrete output, right, Nakina? Yes? ঠিক আছে?
Yes, sir.
Identifying a tumor, let's say you take an image of a tumor and from there you identify is the tumor a benign tumor or a malignant tumor. What do you think?
Discrete.
Discrete.
Of course, discrete. There's nothing else here, just benign or malignant. Okay, so this is discrete. Okay, maybe the tumor that you have is a benign tumor. Okay, a small surgery would be good enough. And if it's malignant or cancerous tumor, sadly, it's a bad condition now. So this is discrete. Measuring sea level. Okay, so you want to measure the sea level. What do you think? Discrete or continuous?
Continuous.
Continuous. It can take any value within a given range, so it can be continuous. Clear, Nakina? Is that right?
Yes, sir.
Measuring the stock price.
So continuous.
Continuous, because stock price value can be anything. Within a given range, of course, right? Yeah. Identifying a handwritten Bangla character.
Discrete.
Discrete. There could be a lot of Bangla characters, doesn't matter, but you still identify only those Bangla characters. It cannot have any other values, right, Nakina? Okay, so it is discrete. Clear, Nakina? Is that okay? Now imagine we are creating an application যেখানে তোমরা exam দিবা, exam দেওয়ার পর তোমাদের exam script কি করলা, it's going to score the exam script automatically. What do you think would be the value?
Continuous.
What would be this one? Is it discrete or continuous?
Continuous.
Continuous, right, Nakina? Yeah, so this is going to be continuous. Clear? Is that okay, Nakina? ঠিক আছে? Are we good?
Yes, sir.
All right, good. So we understand what does discrete mean and what does continuous mean now. Okay, getting back over here. So for classification problem, okay, so as I was talking about supervised learning, so let's not worry about unsupervised learning now. Let's talk about supervised learning. In case of supervised learning, if the y value that you have is discrete, y is discrete, then what kind of problem you are solving? You are solving the classification problem. Am I clear, Nakina? Is that okay? Yes?
Yes, sir.
But if the y value that you have in your supervised in your data set, if that y is not discrete, it is continuous, then what kind of problem you are solving now?
Regression.
You are solving a regression problem now. Okay? So now let me give you some examples of classification problems and regression problems. So, okay, classification problem. Example, classifying whether an email is a spam email or not. So you've got a bunch of emails, and from that email, from that bunch of data set, you're learning whether this email that you have, whether an email that you have is a spam email or a regular email. So it's a key problem. Classification and regression.
Classification.
Why? Because what are you predicting? You're predicting whether it's a spam or regular. So that's a discrete values, discrete set of output values, right? So it's a classification problem. And if you think carefully, why do we call it classification? Because it classifies whether it's a spam email or whether a particular email is a regular email. Is that okay, Nakina? Yes?
Yes, sir.
বুঝতে পারছি?
Yes, sir.
Are we good? Acha. Whether a tumor is a malignant tumor or a benign tumor, this is also a classification problem, because you take a tumor and you look at the tumor and you then classify it as either malignant or benign depending on its features. Okay, so again you're classifying between two discrete values, malignant or benign. Okay, classifying from medical records. From the medical records, if you want to classify whether a pregnancy is a high-risk pregnancy or not a high-risk pregnancy, that's also a classification problem. So, you know, you have medical records of pregnant mothers, and from there you created a model that's able to actually look at a medical record and predict whether this particular woman is actually suffering from high-risk pregnancy or not. So now if a new patients come in and we just give those medical records, her medical records into the system, and if the system predicts whether it's a high-risk pregnancy we're looking at or a low-risk pregnancy we're looking at, you know, what kind of problem are we solving? We are solving a classification problem. It classifies a patient as a high pregnancy, you know, risk patient or a low pregnancy risk patient, a low risk pregnancy patient, right, Nakina? Clear? Is that okay? Are we understanding classification?
Yes, sir.
Okay. And here's another example. Classify the species of iris. Iris is a flower. Okay. Ebong a iris flowers iris flower. I think there are 4 kinds of iris flowers. Okay. Iris setosa, iris versicolor, iris virginica, and I 4 or 3. Let's see. Iris flower. Okay, let's have a look. Iris flower. Here we go. Let's see. Okay, so actually we had it over here. So you can see the images over here. Okay, right? Okay, so, and this is an iris flower, and they can be of certain kinds. Okay, all right. Let me go right. Iris setosa. Oh, naam dai. Versicolor. We have got iris versicolor, for example, এক ধরনের iris flower. তারপর iris setosa বলে এক ধরনের flower আছে, ঠিক আছে? All right. So if you are able to classify whether it's an iris versicolor, iris virginica, or iris setosa, 3 ধরনের, sorry, 4 ধরনের না, 3 ধরনের. These are iris setosa, iris versicolor, and iris virginica. So image থেকে বলা কোন ধরনের iris flower it is. What kind of problem you are solving now?
Classification.
Classification problem, because you're looking at a iris flower and you are actually, you know, finding whether it's a iris versicolor, virginica, or iris setosa. So 3 ধরনের হতে পারে. So one of the 3. So this is classification. So you have discrete set of outputs. So you have only these 3 outputs, right, Nakina? Yeah. Okay, it cannot be anything other than these 3. So this is definitely a classification problem. Regression problems are those problems in which the y value that you have, the outputs that we have continuous values. Example, if you want to predict the price of a house, for example, you want to predict the price of a house depending on location, size of the area, number of rooms, and maybe other features are there. Now, price of the house, it can be any value within a given range. So that's a regression problem, because here y is continuous. Clear? So similarly, I've given examples like, you know, measuring the height of a sea level. That is also a regression problem. Measuring the stock price. That's also, you know, a regression problem. So whether your supervised learning problem is a classification problem or a regression problem depends largely on the value of y. If the value of y is discrete, we're looking at a classification problem. If the value of y is, you know, continuous, we're looking at a regression problem. Is that okay, Nakina? Are we good? ঠিক আছে?
Yes, sir.
Yes, sir.
Okay. So we understand classification, regression, and stuff like that. Classification can only, it's not just because y is discrete. It is true y is discrete, but classification only because when you look at a so for example, you have a lot of data set, spam data set, as well as not a spam data set. So you've got some labeled data set. So this is your labeled data set, right? Like now, okay, labeled data set. So some data sets are labeled as spam, and some data are labeled as not spam, and you use an algorithm to learn from the data whether it's basically this is your model, and you learn from the data whether this particular email is a spam or not spam. Now what happens is when you now give a new email that's coming, new incoming email comes, and then when you feed it into this model and looking at that model, looking at this data and looking at the model, you actually map it whether it's a spam email or a regular email. Is that clear, Nakina? Right? So why do we call it a classification? We call it a classification of course this y value that we predict is discrete, but we really call it classification because we are classifying one categories of emails from another categories of emails. Clear, Nakina? Is that okay? So we are classifying. Is that okay? Right? Understandable?
Yes, sir.
Okay. Now, so classification. Okay, I think let's not worry about this.
Sir,
yeah.
লেবেল ডাটা বলতে কি বোঝায় আসলে আমি
জি বলেন।
বলছি লেবেল ডাটা বলতে কি বোঝায় আমি
লেবেল ডাটা বলতে বোঝাচ্ছি আমি এই যে এখানে যে ডেটা সেটটা ছিল, এই যে দেখেন, হ্যাঁ, এখানে আছে আউটলুক হচ্ছে সানি, টেম্পারেচার হচ্ছে হট, হিউমিডিটি হচ্ছে হাই, উইন্ডি হচ্ছে ফলস, এবং ওই সময় এটা কি Bob did not play. So we have labeled the corresponding output as well. ঠিক আছে নাকি না? This has been labeled. So the y value is labeled. The correct y value is given. So that's the labeled one. Clear নাকি না? Is that okay? Yes?
Yes, sir.
Okay. In the context of these emails, if you think carefully, why we call it labeled data set is because you have an email. একটা ইমেইলে কি কি আছে বলেন তো? What are the different things? Like for example, এখানে যেমন ডিফারেন্ট ফিচার্স চিন্তা করেছেন, অ্যালিস যেমন চিন্তা করেছে, আচ্ছা আউটলুক দেখি, টেম্পারেচার দেখি, হিউমিডিটি দেখি, দেখেন একটা ইমেল থেকে হোয়াট আর দ্য ডিফারেন্ট ফিচার্স ইউ ক্যান থিঙ্ক অফ? একটা ইমেইলের মধ্যে কি কি আছে বলেন?
Sender's address.
হ্যাঁ, সেন্ডারস ইমেল অ্যাড্রেস, রিসিভারস ইমেল অ্যাড্রেস, ইমেলটাতে কোনো অ্যাটাচমেন্ট আছে নাকি, ঠিক আছে, অ্যাটাচমেন্ট সাইজ কেমন হয়, ইমেইলের লেখার মধ্যে কোনো লিঙ্ক আছে কি না, ঠিক আছে, কোনো স্পেসিফিক ওয়ার্ডস ইউজ করেছে, অনেক কিছু হতে পারে, তাই না নাকি না? ইয়েস। ইমেইলের বডির লেন্থ কত হচ্ছে, তোমার সাবজেক্টের লেন্থ কত হচ্ছে, we can measure all these things. Then all of these things would be these features, these different parameters that we're looking at. তাই না নাকি না? Is that right? Yes? বুঝতে পারছি নাকি না? Hello?
Yes, sir.
Yeah, and then আমার যদি অ্যাকচুয়ালি একটা অলরেডি ডেটা সেট থাকে, যে এই ডেটা সেটে আমার কাছে কিছু রেগুলার ইমেলস আছে এবং কিছু স্প্যাম ইমেলস আছে, এবং আমি এই দিস ডিফারেন্ট প্যারামিটার্স এগুলাকে আমি আইডেন্টিফাই করলাম, এবং অলসো উই আর লেবেলিং, আচ্ছা এই ইমেলটা হচ্ছে স্প্যাম, এই ইমেলটা হচ্ছে রেগুলার, এটা স্প্যাম, এটা রেগুলার, ঠিক আছে? সো উই আর লেবেলিং ইট, ওকে দিস আর দ্য ফিচার্স এন্ড দ্যাটস দ্য করেসপন্ডিং আউটপুট. Okay, so if you're labeling the corresponding output, okay, that means you've labeled your data set. The data set has been labeled. Is that okay, Nakina?
Okay, sir.
Hello?
Yes, sir.
Okay, so I hope you understand what this label data set means, right? I'll ignore this diagram for the time being. We'll look at this later on, okay? Regression. Now, regression is when the y value that you have is not discrete, rather it is continuous, okay? And we gave you some examples of that. I think I'm going to talk about this correlation, regression in the class when we discuss about regression, ঠিক আছে? এখন আপাতত not to worry about that. Unsupervised learning is a little bit different from supervised learning. In case of supervised learning, in a data set, the data set that you have is labeled. So you have got X as well as Y, right, Nakina? Clear? But in case of an unsupervised learning, you do not have any Y. You just have X. So unsupervised learning algorithm takes a set of input that contains only the inputs. Inputs means the X values. So you contain only the X values and there is no Y values. Clear, Nakina? Is that okay? Is it clear, Nakina?
Yes, sir.
Yes, sir.
Okay. So the algorithm therefore learns from the algorithm therefore learns from the test data, not trained data. The algorithm learns from the trained data that has not been labeled. That has not been labeled কেন বলছি কারণ এখানে কোনো y value নাই, correct y value টা কি হবে সেটা we do not know. So it has not been labeled, so it's unlabeled. Is that okay, Nakina? So in case of unsupervised learning, the data set is unlabeled. Is that okay, Nakina? Yeah? Are we good?
Yes, sir.
Yes, sir.
So what can we do with unsupervised learning? Sometimes, you have a lot of data sets. Okay? তোমার কাছে কিছু bunch of data আছে. Okay? So you've got instance number 1, these are the data. Instance number 2, these are the data. Instance number 3, this is the data. But you do not have it labeled. So you really don't know what to predict. Okay? But you can do some interesting stuff. You can look at this data and can ask an algorithm, okay, can you find different patterns here? So what are the different patterns can we have? Can we cluster the data points? So things like we can find structures in the data. We can do like grouping, clustering of data points. These are unsupervised learning. These are what unsupervised learning would do. So you do not as such predict a particular Y value because you don't have a Y value in a unsupervised learning, but you can do other things like you can just give some data and say, okay, find some patterns from this data. So you can do something like, okay, it's going to group certain data points. So this data point, and some of data points, it can group it under one cluster because they are similar. Group other data points in another cluster that are similar, and things like that. So we can do things like that. So we can do like grouping or clustering the data points. Okay. এটা করে কি লাভ? ঠিক আছে, so we're going to look at it, what is the advantage of grouping some data points or clustering some data points. We'll look at these ones. Okay, all right, so far so good, Nakina? Okay, now let me give an example. Okay, let me give an example of a particular problem called the cocktail party problem. So cocktail party problem হচ্ছে অনেকটা এরকম যে let's say অনেক ধরনের সাউন্ড আসতেছে. There's a sound from a car, maybe it's a police car, someone speaking, someone else is speaking, a group of people speaking. So you can have a mixture of sounds, and you have got certain microphones at certain points. Okay, so this microphone এটা যেভাবে সাউন্ডগুলো নিবে আর এই মাইক্রোফোনটা যেভাবে নিবে আর এই মাইক্রোফোনটা যেভাবে নিবে, because there are different location, there would be sometimes a little bit different. So I have not said the kunta ki predict করে, but I can use this different sound and we can find out patterns, and we can use these patterns to separate the sounds, and we can find out, okay, there is a police car sound, alada sound gula pattern gula বের করতে পারবো. So we can do things like that. Now this is a very classic problem in unsupervised learning called cocktail party problem. So we can do things like that. Okay, I think I'll give you a easier example. Okay, so let me give an easier example in unsupervised learning. Okay, Ernest Rutherford, okay, a person who actually got his Nobel Prize in chemistry, but he famously said that all science is either physics or stamp collecting. But well, he said it long time back. But the way we do science is now a bit different from the way science was done at that time. So he thought, physics was the actual science, because in physics you learn about different rules, okay, and you have different ways of, like for example, you've got the Newton's first law, third law, so many rules, okay, energy conservation, law of conservation of energy, law of conservation of momentum, and so it's like you know how things behave, okay. And other sciences are like stamp collecting. You're just like collecting different data, but There's nothing you can learn from that. So that's why he used to call those sciences as stamp collecting. Particularly, he meant chemistry at that time, although he got a Nobel Prize in chemistry. However, that has changed a lot. Collecting the data has values. Okay? So we can use the data to do different kinds of things. Think about chemistry itself. Chemistry এই টেবিলটা তো আপনাদের মনে হয় সবাই জানেন নাকি না? What is this table called?
Periodic.
Periodic table. Now, if you look at this carefully, how did someone come up with this periodic table? Any idea? How did someone come up with this periodic table? So now this periodic table has a rich history, and it has been modified many times. There are many versions of periodic table. This is the final versions of periodic table where everyone's happy with this periodic table, because this periodic table is unique in a way. How is it unique? You know, these are the group 1 elements. They have similar features, right, Nakina? Yes, these are the these have different features. Transition elements, they have different features. Okay, right? They have different features. So they're grouping them, they're clustering them, these elements, because they have certain features that are common to them. They're clustering them as this because they have certain features that are common to them. Is that right, Nakina? Clear? Okay. Now, is it possible then যে আমরা এটা না করে আমরা প্রত্যেকটা এলিমেন্টের লাইক হাইড্রোজেন, হিলিয়াম, লিথিয়াম, বেরিলিয়াম, ঠিক আছে, প্রত্যেকটা এলিমেন্টের ডিফারেন্ট প্রপার্টিজ গুলা আমরা রেকর্ড করলাম, ঠিক আছে, reaction with oxygen, reaction with water, color, I don't know, many things we can do. And then we can run an unsupervised learning on them to find out, okay, এগুলোর মধ্যে কোনগুলা which are which have similarities, cluster them. So in that way we can actually cluster them, and we can have different groups of elements under one category te rakha jay. Other groups of elements can be kept in another category, and thus we can actually create our own periodic table. And in fact, there was one guy who actually has done this one, ঠিক আছে, and he actually trained machine learning algorithms, ঠিক আছে, on group of elements, and he recreated this periodic table, which was a very interesting thing to do. Okay, so early days, this is science. Creating this periodic table, it was many years of effort, but now with computers in it, we can just do these things in a matter of seconds if you have the data set. Okay, if you have the data set. So I hope you understand that what we can do with unsupervised learning. Now, we don't predict anything, but we can cluster them into different categories, and we can group them into different categories and stuff like that. Yeah, is that understandable, Nakina? Hello?
Yes, sir.
Right. Let me give you another example. For example, do we have time left? How much time is left? We have 3 or 4 minutes. So
Yes.
Actually, let's take a few examples to understand that. Okay. Let's say, Netflix. I'm sure most of you have used Netflix, right, Nakina? Yeah?
Yes, sir.
Yes. Okay. So Netflix, now when you create a Netflix account, for example, okay, so they have your profile, okay, user profile আছে কিছু জিনিস। Also, in Netflix, different movies দেখছো, ঠিক আছে? So what are the different kinds of movies that you like? What are the kinds of movies that you see? For how many durations do you see them? Do you see movies? Do you see series? A lot of things they can actually record. And when they record these things, they can create a database now. This is the user. এটা হচ্ছে তার features গুলো. These are the different things that he does. This is another user. These are the things that he does. And this is another feature. These are the things that she does. Okay? And so they have a data set. And now what we can do is, we are not predicting any Y value. There is no Y value, but we have some data sets of different, users. And then what can be done is, we can apply unsupervised learning on that and find out, okay, A users কোন users গুলো similar, put them into one category, which other users are similar, put them into another categories. And so we can actually have some different clusters of, you know, users. Is that okay, Nakina? Right?
Yes, sir.
If we can do that, now a new user comes in, and if they can use new user to, and if they use this test user to find out je she kon cluster e belong kore, so if they can identify কোন cluster belong করে, then they actually know আচ্ছা ওই cluster এর মানুষরা কোন কোন জিনিস দেখতে পছন্দ করে, and then the Netflix can actually recommend those sort of things to this user because that would be more relevant to this person. Is that right, Nakina? Clear? So this is where we can use unsupervised learning. বুঝতে পারছি নাকি না?
Yes, sir.
Yes,
Okay,
sir.
so that's a simple example, the recommendation system. ঠিক আছে, we can use some unsupervised learning
স্যার
there.
ওই যে ইউটিউবে যখন ভিডিও দেখা হয়
A
recommend
similar
করে,
idea, but there are other things in recommendation system like collaborative filtering and stuff like that. We're not going to go into those things right now, but we're just trying to understand what does unsupervised learning really does. ঠিক আছে, ইউটিউবে যখন তুমি তোমাকে কোনো কিছু সাজেস্ট করে, they make sure that to understand it you must be logged in. ঠিক আছে, logged in না থাকলে হয়তো বা অনেক সময় ইয়ে করে না, but when you're logged in against a profile they actually monitor you and they actually understand what kind of user you are, what kind of things you like and stuff like that. Okay, is that clear, Nakina? Did you understand unsupervised learning? Hello?
Yes, sir.
Yes,
Yeah.
sir. Yes.
Here's another example. Okay, now if you are interested to know about, or if you have some interest in stars, okay, you may know there are different kinds of stars. There's a kind of star called the red giant stars. Then we have stars like red supergiants, blue giants, blue supergiant. These are the main sequence stars. These are all main sequence stars. Some of them are different. Okay, these are called the white dwarf stars. Okay, and there are other stars as well. Because they have different stars and they are categorized as different depending on certain properties they have. It's depending on their stellar properties, right? Okay, now, all right. Awesome. So এগুলা এখন যখন ফিজিসিস্টরা যারা অ্যাস্ট্রোফিজিক্স নিয়ে কাজ করে, they did that through experimentation. They had a lot of data and stuff like that, and they then actually, you know, looked at the patterns and they figured out certain, you know, classification. They did some sort of clustering. But just imagine, we actually don't need to do it manually. We could have done it if we had this entire data set. Okay, we could just manually find out what are the different kinds of, you know, clusters that we have. Actually, in fact, even if we now have the data and we try to do it, we might get different clusters. Because your machine learning algorithm could actually cluster them in a different way. Would happen, right, Nakina? So that's again where you can apply unsupervised learning very easily on a data set to figure these things out. Nowadays, astrophysicists, physicists, they have to work, particularly astrophysicists, they deal with huge amount of data. ঠিক আছে, এবং ওরা কিন্তু আসলে অনেক আগের থেকেই they used to use huge amount of data. For example, in astrophysics, the most, I think, celebrated astrophysics was অনেক আগে Tycho Brahe. I don't know if you have heard of his name, Tycho Brahe. ঠিক আছে, and Tycho Brahe actually published huge amount of astronomical data. ঠিক আছে, and lot of different kinds of you know, theories and laws যেগুলো আসছে সেগুলো অনেকগুলো আসছে Tycho Brahe data থেকে. For example, Kepler's law, very famously known. Actually, Kepler looked into the Tycho Brahe's data set and figured out some interesting patterns from there. ঠিক আছে, so physicists are also the people who use a lot of data and data points. Our modern days physicists also use machine learning nowadays. ঠিক আছে, things have changed a lot. ঠিক আছে, so machine learning is not something that only computer science people do. People from other backgrounds, particularly those who have to work on different data and understand data, machine learning is the two techniques to use and apply. Is that okay, Nakina? I don't think we want to discuss reinforcement learning right now. We'll stop here because we're running out of time. We wanted to talk about issues related to AI, particularly problems related to AI, but we are running out of time, so we'll look at it in the next class. No problem. Okay, so I'll stop the recording and